EV Expert, e-learning, diagnosis. PRA, Power Relay Assembly. Overview. What is the high voltage power source for EVs? That's right, it is the high voltage battery. The PRA is responsible for supplying and shutting off the high voltage battery power, pre-charging the inverter capacitor before the plus main relay connection, and measuring the current and temperature. So let's take a look at the PRA. PRA, Power Relay Assembly. Components and main relay system. The PRA consists of the plus main relay, minus main relay, pre-charge relay, pre-charge resistor, and electric current sensor. The main relay consists of a plus relay and a minus relay to supply or disconnect the power of the high voltage battery to the high voltage junction block. The high voltage circuit is fully isolated from the 12-volt low voltage circuit. The pre-charge relay charges the inverter capacitor in advance to be equal to the voltage of the high voltage battery prior to the operation of the plus main relay. This prevents the initial surge current caused by the large voltage difference between the high voltage battery and the capacitor. The pre-charge resistor is connected in series with the pre-charge relay to reduce the pre-charge current of the inverter capacitor. The electric current sensor measures the amount of electric current discharged from and charged to the high voltage battery and sends this information to the BMU. When the vehicle is in a normal state, the power from the high voltage battery supplies power to the PE components through a plus main relay and a minus main relay. At this time, the BMU monitors the amount of current in real time using the current sensor. If the current is higher than the value for ensuring safety, the BMU shuts off the main relay of the PRA to cut off the supply of high voltage power. Now let's take a closer look at the pre-charge relay. EVs use high voltage. If such high voltage flows directly into the capacitors of PE system at startup, electric contacts of the main relays or PE components can be damaged. Pre-charge relays and pre-charge resistor are installed to prevent such damage. The pre-charge relay changes the voltage of the inverter capacitor equal to the voltage of the high voltage battery to enter the EV-ready state. At this time, the voltage of the capacitor is charged in advance with a small current equal to the voltage of the high voltage battery through the pre-charge relay and resistor. Through this preliminary process, it is possible to protect the high voltage circuit by minimizing surge shock that may occur when the plus main relay is immediately operated. PRA, Power Relay Assembly. Main relay inspection. As we just learned, the PRA plays a critical role during high voltage supply. Then, how can we diagnose the normal operation of PRA? There are two methods. One is to measure the resistance of each relay, and the other is to check the operation sound of the relay through actuation test with GDS. Then, let's first take a look at relay resistance measurement. The specification of the coil resistance of the plus and minus main relay is 26.2 ohms, and it can be determined that the value is normal up to plus or minus 10% when measuring. The specification of the pre-charge relay coil resistance is about 103 ohms, and it can be determined that the value is normal up to plus or minus 10% when measuring. The specification of the pre-charge resistance is 40 ohms. Let's perform actuation test with GDS and check the relay operating sound. Select BMS from Actuation Test. Then select Main Relay minus on. And click Start. Do you hear the relay operating sound? If you hear this, the relay coil operation is normal. Repeat the same procedure to check main relay minus on and pre-charge relay on as well. And click Start. However, there are points to be noted. Even if the coil resistance value and the relay operating sound are normal, the electrical contact point of the relay may not be considered normal. Therefore, if the problem persists in the vehicle, it is necessary to check the continuity of the relay.